in scheme, when you call a procedure, what happens is this. 1. Okay, so first step, evaluate the sub-expressions that tell you what function you're calling and what arguments you're giving it. So when you say something like plus times 2, 3, 7, this is saying we have to evaluate the times 2, 3 as the first step in doing this whole thing. We also have to evaluate the plus sign, which we do by looking up its value and finding out that it's the addition procedure. And we have to evaluate the 7, but numbers are self-evaluating. So those two are pretty trivial. That one actually takes a little work. Okay, so that's step 1. Now, we're going to be talking now about how to evaluate a call to a procedure that you wrote, not a primitive procedure. Step 1 is the same for primitives also, but now it gets specific to procedures that you created. So substitute actual argument values for formal parameters in the body of the procedure that you're calling. And step 3, evaluate the modified body. Okay? But right now, my focus is not on this substitution business, although that's in the book. They talk about it, so here it is. It's the fact that we evaluate arguments first. It doesn't have to be that way. We could have a rule that says, take the actual argument expressions and substitute them for the formal parameters. So that we would just have a bigger and bigger body. And that's called normal order evaluation. And I'm going to show you what I have here is 2 little scheme interpreters that sort of show you their intermediate workings, one of which does applicative order and one of which does normal order. So def is like define, but for my hacked up little scheme here. So this is the example in the lecture notes. I'm just typing it exactly in. So f of AB is plus g of a b. And def g of x to be times 3x. And now I'm going to say, in applicative order, compute f of plus 2, 3 and minus 15, 6. Close the minus, close the f, close the flick. Okay, so here's what happened. First, we evaluate plus 2, 3. And I'm leaving out some steps here because primitives we're just sort of doing by magic. So plus 2, 3 gives the value 5. Minus 15, 6 gives the value 9. So now I substitute those values in to the call to f. So f of 5 and 9. The body of f is plus g of a, b. That's up here. Oops. Here's the body of f, plus g of a, b. So that's plus g of 5, 9. Substituting 5 for a and 9 for b. So now I have to do g of 5. G of x is times 3x. 5 is self-evaluating, so that's pretty easy. We just throw 5 in place of x. We get times 3, 5. That's 15. And now finally I can add 15 and 9. And I get 24. Okay? Okay, now let's say normal f of plus 2, 3 minus 15, 6. Okay, so look at the difference. This time, I don't start. Last time around, let me back this. Oops. So last time around, we started by doing plus 2, 3 and getting 6. And from then on in the computation, we're dealing with 6 rather than plus 2, 3. This time, I just substitute the plus 2, 3 and the minus 15, 6 into the body of f. Body of f is plus g of a, b. So we get plus g of plus 2, 3 minus 15, 6. And similarly, we do g of plus 2, 3 by substituting plus 2, 3, not 5, but plus 2, 3, into the body of g. So now, the body of g is a call to a primitive procedure. When we call primitives, that's when we finally have to start evaluating things. So times 3 plus 2, 3, okay, times is a primitive, so I have to find out at this point what plus 2, 3 is. The answer is 5. So I do 3 times 5 is 15. Now at this point, I do 15 minus 6. I get 9. I add 15 and 9. I get 24. So you get the same answer either way, but you go through a different series of steps. All right? So if you get the same answer either way, why am I making this fuss about it? And the answer is I want to make the point to you that you get the same answer only if you're doing functional programming. So to make this point, I'm going to define 0 of x to be minus xx. So this is a function that should always return 0 no matter what argument you give it, right? Minus xx, no matter what x is, the answer is 0. And now, in applicative order, I'm going to ask for 0 of random 10. Random is a procedure that takes a positive integer argument and it returns a non-negative integer less than the argument. So it's going to return some number between 0 and 9. So what happens? I call random 10. I happen to get the answer 7. So in applicative order, in the call to 0, the first thing we do is evaluate subexpressions. So we evaluate the random 10. We get the answer 7. Substitute that 7 in place of the random 10. So we're calling 0 of 7 with the actual argument value. And so we get 7 minus 7 is 0. Normal 0, random 10. This time something else happens. In normal order, we use the actual argument expression as the thing we give the procedure. So I take the expression random 10 and I substitute that into the body of 0. The body of 0 is back here someplace. Yep. Oops. 0 is defined. 0 of x is minus xx. So I substitute the actual argument expression random 10 into minus xx. I get minus random 10, random 10. I call random 10. I get the answer 9. I call random 10, I get the answer 8. 9 minus 8 is not 0, it's 1. So this is an example that gives different answers in normal and applicative order. Why is that? Why did we get the same answer with f and g, and we get different answers with 0 and random? Yes? Random was called twice, and it doesn't always return the same thing, right? It doesn't always return the same thing for the same argument. Okay? Saying that a different way, random is not a function. By using random, I'm breaking the rules of functional programming. Because a function, by definition, is a procedure that always gives you the same answer when you call it with the same inputs. Right? Random 10 doesn't always give you the same answer. Since random is not a function, since I'm not doing functional programming, the order in which things happen matters. Okay? And this is the big moral that I want you to take away from this whole exercise. If you're doing functional programming, it doesn't matter in terms of what answer you get, what order things happen in. If you're doing non-functional programming, then it does matter what order things happen in. So, for instance, when you call a function with several different arguments, in what order do we evaluate the argument expressions? Well, the official answer is Scheme does not specify that. It has to happen in some order, but it could be, you know, first one, then the last one, and then the second one, and then the next to last one. It's perfectly legal for a Scheme system to do it that way. Well, if you're doing functional programming, you don't care what order they're evaluated in, because you're confident that the result of your program will not depend on that. If you're doing non-functional programming, then you do care about the order.